Alright, so in this section we're looking at improper integrals. So directions are tell me if the proper integral converges or diverges. Alright, so we look, and if we've got the infinity up here, okay, I've given you your formulas, it's going to be the limit as b approaches infinity, and you're going to replace that infinity up there with a b. Keep the 1, and you need to integrate 1 over x dx. Okay, so I'm just going to deal with the integration part first. We know that 1 over x integrates as the natural log of the absolute value of x. Okay, and I want to evaluate it from 1 to b. So I have the natural log of b minus the natural log of 1, and we know the natural log of 1 is 0. It's going to go away, so what I need to do is evaluate the limit as b approaches infinity of natural log of b. So on the first page of your notes, I said make sure you review your limits and infinity rules for Cal 1. And we know if the higher power is on top, like this one is, that this is going to go to positive infinity. And if you don't get a number answer, you know that it diverges. Okay. Alright, so let's look at the next one. Alright, so again, I've got my infinity at the top, so it's the limit as b goes to infinity, integral of 1 to b of 1 over x squared dx. So I'm just going to ignore that limit part first and get it integrated. So I need to bring it to the top. So if I add 1 to it and divide by the new power, I get negative 1 over x from 1 to b. So I've got negative 1 over b minus a negative 1 over 1. So this turns into the limit as b approaches infinity of what's left. So negative 1 over b plus 1. Okay, well, looking at limit and infinity rules, my higher power b, when it's on the bottom, you know that piece zeroes out. So then I'm just left with 0 plus 1 or 1. If you get a number answer, then this thing converges. Okay. Alright, so moving on. Now, it's got the negative infinity at the bottom. So it's going to be a slightly different formula. It's the limit as a approaches negative infinity, and you replace that negative infinity with a. I'm going to go ahead and for space sake move this up, and that's a negative 3/2 when I move it up. So let's do the u substitution. U would be 1 minus 2x, and d would be negative 2 dx. So this becomes u to the negative 3/2. Don't have du, so I need a negative 2 in there, so I'm going to cancel it out with a negative 1/2. Okay. So if I get ready to integrate this, if I add 1 to it, let's say 2 over 2, I get a negative 1/2, and dividing by a negative 1/2 is the same as multiplying by negative 2 over 1. So those cancel, right? And the negatives cancel, and so I'm left with u to the negative 1/2. Okay, or 1 over the square root of u, or 1 over the square root of 1 minus 2x. And I'm looking at it from a to 0. So let's plug that in. So that would be 1 over square root of 1 minus 2 times 0 minus 1 over the square root of 1 minus 2a. Okay, so this is the limit as a approaches negative infinity. That's just going to give me 1 minus 1 over the square root of 1 minus 2a. Okay, so again, when you're doing limits at infinity or negative infinity, you're always looking for your higher power of, usually we have x, but my variable here is a. So if your higher power of a is in the bottom, that piece zeroes out. So the only thing left is just 1, and as long as I get a number answer, I get to say converges. Okay. Alright, so same thing here. Let's say, alright, limit as b approaches infinity, 0 to b, 2x e to the negative x squared dx. Alright, so if I integrate it, I'm going to let u be the exponent, and d would be a negative 2x dx. So I almost have everything I need. That's e to the u, and that part's gone. I need negative 2x dx when I have positive 2x dx, so I'm going to multiply in by that negative and cancel it out. and there's du, and we know e to the u integrates as negative, or e to the u integrates as e to the u, and I have that negative out front, and I'm going from 0 to b. So that's negative e to the b minus a negative e to the 0. Okay. So this is the limit as b approaches infinity of negative e to the b plus e to the 0. We know anything to 0 power is what? Oh, I made a mistake. Let me go back. I'm sorry. Back up, back up, back up. I got a little ahead of myself. It's negative e. I didn't replace u. Big mistake on my part. Glad I caught that. So that's a negative x squared from 0 to b. Okay, so that changes our problem completely. Sorry about that. I'm not paying attention. Okay, so let's now look at it. So the limit as b approaches infinity. Okay, negative e to the negative b squared. Okay, and that's going to change to a plus. Anything with 0 power is equal to 1. Now, let's write this a little bit different. Okay, when you plug in positive numbers for b and square them, they stay positive. But this negative is not going to go away on the outside, so you know that you can't have negative exponents. So if they're on the top, you can move them to the bottom. So it kind of changes our problem, because at first glance it looked like the higher power was on top, but now if I look at it, the higher power b is on the bottom. So this piece zeroes out and I get 1 again, and I get to say that it converges. So be careful with that, okay? Because of that negative sign, it moved that exponent to the bottom. All right, 2 more left. Let's look at this one. All right, so this is the limit as a approaches negative infinity, integral a to the 1 of e to the x dx. Okay, so if I integrate it, it is just e to the x from a to 1. So it'd be e to the 1 minus e to the a. Now, this is the limit as a approaches negative infinity of e to e to the 1 is just e, minus e to the a. So you want to think about this. On first glance, it looks like the higher power is on top, okay? But what kind of numbers are you plugging in for a? You're plugging in bigger and bigger, or smaller and smaller and smaller negative numbers. You know, you're plugging in -1, -2, -3, and it's going to get lower and lower and lower like that. So if these are going to become negative, where do they have to go? The bottom, right? And so it's going to kind of look like that, and that zeroes out, and you just get e, and you get to say converges. Now, had it been, you know, the integral of from, let's say 1 to b, okay, and you had the come down to the end with the limit as b approaches infinity of that same thing, okay, then now you're plugging in positive numbers here, so that stays on top, and that would diverge. Okay, but because I was plugging in negative numbers here, it got to shove that to the bottom, which means higher powers on bottom and the limit was 0. Okay. All right, so we'll do that last one, and